Hello, I will talk about my GSoC project, Cape Compability Layer. My name is Kai Yamada. Nice to meet you. My background. I'm interested in using devices that have served some purpose. This is a gaming device, but gaming is very tired, so I changed this device as a generic Linux device using custom firmware. I like these reusing things. However, the custom firmware was based on GPL source code. GPL is very useful, but uh, there was a lot of things I didn't understand. So it is difficult to change Linux more dynamically. So I need more knowledge of Linux, especially device drivers for connecting external GPIOs to enhance possibility of the device. With this in mind, I applied for this GSoC project in order to become more familiar with Linux. And if this project succeeded, I want to be a Linux contributor, and I will continue to the Linux contribution. And finally, I want to be a engineer, Linux board support package engineer. I want to be. Abstract. Through my GSoC project, I will write configuration information for linkage to connect devices to a single board computer called BeagleBoard. This configuration information is called a device tree. This time, we will write a device tree overlay suitable for removable device called Cape. Professional word in describe flowing slides, so please listen to me. Contents. First, I will talk about the professional word, BeagleBoard, Cape Compability Layer, and device tree overlay. Then the 2020 GSoC works by my mentor, and then I will talk about 3 programs in 2020, and I give some solution for 2022 project. And then finally, I will talk about the benefit. What is BeagleBoard? BeagleBoard is a Linux-based single-board computer. It offers the ability to use additional features by installing capes. This is relay cape, motor cape, and a robotics cape, and a lot of cape is available. And also lot of board is available, BeagleBoard Black, BeagleBoard AI, and other boards. Just insert board you would like to use, and then you can use on Linux. It is very easy. However, BeagleBoard pin have multiple functions per P, so development is very difficult because assignment is different among the device. So hardware header pin is same, but internal pin assignment is different. So without Cape Compability Layer, you have to make code separately by BeagleBoard. So to reduce the cost to make redundant code, we can use Cape Compability Layer. To implement Cape Compability Layer, we use device tree overlay. So next, I will talk about device tree overlay. Before device tree overlay, I will describe device tree. Device tree is data external kernel about the configuration of hardware in ARM and other embedded Linux. Please look at this figure. There are settings which device driver will be used on a peripheral, and which is an interrupt and which is a registers, which address the peripheral is exist, and other required setting for peripherals. This is the device tree, and this device tree is loaded only on your boot time. So cape is removable device, so we have to recognize anytime in a user space time. So we have to load the device tree overlay anytime you want. To solve this problem, we can use device tree overlay instead of device tree. Previous work. Until now, thanks to the work of Deepak Khatri, is a 2020 GSoC contributor, and now my mentor had created a device tree overlay for BeagleBoard Black and BeagleBoard AI in kernel 419 for various capes. This is his project page, and then he made a lot of device tree overlay for kernel version 4.19 and very useful. But however, the current implementation has about 3 major areas for improvement. For example, not compatible with a new cape called robotics cape. It will not work with newer versions such as kernel 5.19. And then no demo code explaining how to use each cape. I will describe one by one. First, not compatible with the new cape, robotics cape. The robotics cape is a design for mobile robotics with sensors such as 9-axis and barometric pressure. But no device tree overlay has been created for this device yet. At this time, through this GSoC project, I will add device tree overlay for this robotics cape. Actually, a normal device tree is available for AIM335X, is for BeagleBoard Black, so I will make this device tree as a device tree overlay using editing these codes, and I will make it compatible with all BeagleBoards, including BeagleBoard Black, BeagleBoard AI, and other BeagleBoard on sale. Next, it will not work with newer versions such as kernel 5.10. Deepak Khatri triggered for kernel 4.19, and it do not support 5.10 of the current stable kernel. Please look these codes. For kernel 19, there are device tree overlay and no SoC specific code there. But please look, kernel 5.10, there are AM335X macros, so this device tree overlay only works on kernel BeagleBoard Black. So I will maintain a kernel for 5.10 that currently exists so that it can be used across different SoCs. I will make this 5.10 kernel as 4.9 universal kernel. Final. no demo code explaining how to use each cave. The use of each cave is not organized in a systematic way. Then in a tutorial repository for Cloud9, there is no well organized actually with no instruction on how to use cave. So I will develop the documentation so that even beginners can easily get started. Benefits. A compatibility layer for kernel 5.10 will be added, allowing robotics cave to be handled by BeagleBoard Black and BeagleBoard AI. Also, live robotics control can written for BeagleBoard Black will work on BeagleBoard AI. Various tutorials will be added to the caves to help the user understand how to use it. This too is the main topic for this my kernel project. So please looking forward to my progress. Thank you.